Hello everyone. In this video, we will be going to talk about spaCy library and we will also look some basic operations offered by spaCy. So spaCy is my go-to library for natural language processing tasks. I would venture to say that the case for the majority of NLP experts out there. And it is also the one of the most widely used library and the most important one too. Among the plethora of NLP libraries these days, spaCy really does stand out on its own. If you have used spaCy or for NLP, you will know exactly what I am talking about. And if you are new to the power of spaCy, you are about to enthralled by how multifunctional and flexible this library is. The factors that work in the favor of spaCy are the set of features it offers, the ease of use, and the fact that library is always kept up to date. So this tutorial is a crisp and effective introduction to the spaCy and the various NLP features it offers. So without further ado, let's get started. So if you are new to the spaCy, there are a couple of things you should be aware of. One is spaCy's statistical model and spaCy's processing pipeline. Let's discuss each one of them in detail. So let's start with spaCy's statistical model. spaCy's statistical model. So basically these models are the power engines of spaCy. These models enable spaCy to perform several NLP related tasks such as part of speech tagging, name entity recognition, and dependency parsing. These are topics we have seen in our first introductory video. I will also list the different statistical models in the spaCy along with their specifications. So as you can see, there are Core Web SM, which is an English multitask CNN trained on onto nodes, and the size is about 11 MB. There is one more model, Core Web MD, which is again English multitask CNN trained on onto nodes. But here there is the important factor is like it has been installed with glove vectors trained on common crawl, and the size is about 91 MB. And another is Crawl Web LG, which is English multitask CNN trained on onto nodes, again with glove vectors trained on common crawl, and the size is about 789 MB. So importing any one of these model is very easy. We can import a model by just executing a command, which is spaCy.load, and in the bracket we can specify model.name. Let me show you how. So you just need to type, first we need to install spaCy. So for installing spaCy, we can do pip install spaCy and wait for the library to download it. As you can see, spaCy has been already downloaded here. Now we'll do import spaCy, and in the next line we'll write NLP equals to spaCy dot load, and let's take any model, like I'll take Core Web underscore SM operation plus enter, and voila, your model has been loaded. Now another crucial point about spaCy is the spaCy's processing pipeline. So the first step for a text string when working with spaCy is to pass it to an NLP object. This object is essentially a pipeline of several text pre-processing operations through which the input text string has to go through. Now let me also paste a picture of that pipeline. So as you can see in this figure, the NLP pipeline has multiple components such as tokenizer, tagger, parser, NUR, etc. So the input text string has to go through all these components before we can work on it. So let's create an NLP object. We can do by just type doc equal to NLP, and let's try he went to play basket. Now press Shift plus enter. This is how we create an NLP object. So you can even use the code to figure out the active pipeline components. So to figure out the pipeline components, you have to just type NLP dot pipe underscore names. Press Shift plus Enter. And you can see Talk2Vec, Tagger, Parser, Attribute Ruler, Lematizer, and NER are our current components in our spaCy's pipeline, processing pipeline. And just in case you wish to disable the pipeline components and keep only the tokenizer up and running, then you can use the following code to disable the pipeline component. Just write NLP dot disable underscore pipes, and I want to disable, let's Tagger, and another, let's take Parser. I press Shift plus Enter. Okay, now these components has been disabled from our pipeline. Now to check again the active components, I'll type NLP dot pipe underscore names. Now you can see the names has been removed. So when you only have to tokenize the text, you can then disable the entire pipeline. The tokenization process becomes really fast. For example, you can disable the multiple components of a pipeline by using the following code. I press Shift plus Enter. Okay, so this was about the processing pipeline. Now let's get our hands dirty with spaCy. In this tutorial, we will also learn to perform some various NLP tasks using spaCy. We will start off with the popular NLP task, which is the part of speech tagging, and then we'll move on to name entity recognition. So first, let's start with the part of speech tagging. So in English grammar, the parts of speech tell us what is the function of a word and how it is used in a sentence. So some of the common parts of speech in English are noun, pronoun, adjective, verb, adverb, etc. So POS is the task of automatically assigning the POS tags to all the words of a sentence. It is helpful in various downstream tasks in NLP, such as feature engineering, language understanding, and information extraction. So as you can see in this code, first I've imported spaCy, then I load the Encore web model, then I created the NLP doc, which you have seen before. And now what I have done, I have iterated over the tokens created by this doc. So for token in doc, what I have done, if I've printed the text, and also there is a function which is token.pos. The pos.pos will assign you the respective part of speech for each of the word in the doc. So in the doc, we are having he went to play basketball. So each word he went to play basketball will be assigned with the respective POS. And you can see he is with the pronoun, went with the verb, to with the part of, play with the verb, and basketball with the noun. So this is how spaCy uses part of speech tagging. So the model has correctly identified the POS tags for all words in the sentence. In case you are not sure about any of these tags, then you can simply use the spaCy.explain to figure it out. So let's take spaCy.explain. I'll take PART. Now, like the part, we don't know what part is. When I hit enter, Shift plus Enter, we come to know that it is showing for particle. Now the next function which you are going to see, or the second application, is the name entity recognition. So let's first understand what entities are. So entities are the words or group of words that represent information about common things such as person, locations, organizations, etc. These entities have proper names. For example, consider the following sentence. Donald Trump will meet the chairman of Google in New York City. So let me write it first. So in this sentence, the entities are Donald Trump, Google, and the New York City. So now let's use how spaCy recognize these entities. So again, I'll create a doc equals to NLP, and I'll pass in the above sentence. Okay, let's take another sentence because this will be quite easy. So let's take a tough sentence. Let's take Indians spent over 71 billion on clothes in 2018. Now again, I'll do for entity in doc for ent and doc dot ends, because we want to deal with the entities, so we have to specify end. Now end dot txt end dot label. The label will tell us what are the different entities of the word. So now when I run it, and here you go. Indians has been NOR, over has been 17 billion money, and 2019 has been given entity as state. Now you might be understanding what NORP is. So NORP is basically for nationalities, and you can do again by using, as we have seen, spaCy.explain. If you want to know what the short forms are in, you can write NORP. We can put shift enter. Yeah, nationalities or religious or political groups. So this is how we do name entity recognition via spaCy. So yeah, this was about some basic operations done on spaCy and how spaCy is important in NLP and what are the powers spaCy holds. You can even do the you can even have additional applications of spaCy. One of them is like you can do rule-based matching using spaCy. In rule-based matching is a new addition to spaCy's arsenals. With this spaCy matcher, you can find words and phrases in the text using user-defined rules. So it is basically like regular expression on steroids, you can say. So while regular expression use text patterns to find words and phrases, the spaCy matcher not only use the text patterns, but lexical properties of the word, such as PO tags, dependency tags, and etc. So you can even check it out. So yeah, that was it about this video.